Hello, this is Mr. Farley, and we're talking about displacement under acceleration. So how far something goes when it accelerates. So our first example here is a ball drops for 4 seconds and accelerates at 9.8 meters per second squared. How far does the ball drop in this time? So the equation we're going to use today is delta x equals v sub I t plus 1/2 a t squared. Now, this v sub I is just the initial velocity. This is time. This is the acceleration. And this is time again. But remember that it's squared. All right? Delta x here, that's going to be our how far. That's displacement. All right? So when something drops, what you first need to know is that its initial velocity equals 0. It always starts at a standstill if you're just dropping it. All right? Now it's going to accelerate at 9.8 meters per second. Okay? But the great thing about this is that this whole term, if the initial velocity is 0, becomes 0. That goes away. So we're just left with delta x equals 1/2 a t squared. So we know that our time is 4 seconds. Our acceleration is 9.8 meters per second squared. And we need to find our delta x. So all we have to do is plug these values into that equation, see what we come up with. So I got 1/2 times 9.8 meters per second squared times 4 seconds, and this whole thing is squared. So it's going to become 16 seconds squared right there. So just writing that out, I'm going to get 9.8 meters per second squared times 16 seconds squared divided by 2. That's that 1/2 right there, divides it all by 2. And then I just have to calculate it through, and I'm going to get 78.4, I hope. Now the units, if you look at the units, right here I have meters per second squared, and I'm multiplying by seconds squared, and that's going to give me meters per second squared times seconds squared. Seconds are going to cancel out, and I'm left with meters. So the answer has to be in meters. And that's it. So now let's move on to a harder one. We're going to move on to a new question. A skateboarder moving at 2 meters per second accelerates at 1.5 meters per second squared for 2 seconds. How far does he travel in this time? So we're going to start with the same equation, delta x equals v sub I t plus 1/2 a t squared. And let's write down what we have. So we have t equals 2 seconds. We have initial velocity equals 2 meters per second. And we have acceleration equals 1.5 meters per second squared. So given that, we cannot get rid of this term in the equation, so we're going to have to use the whole thing. So I'm just going to start right here and plug in v sub I is 2 meters per second times my time, which is 2 seconds, plus 1/2 my acceleration, which is 1.5 meters per second squared, times my time squared, which is 2 seconds squared. The whole thing is squared. All right? So looking at just this term, that's going to be 2 times 2. The units of seconds are going to cancel out. So I'm going to be left with 4 meters just for that term. Now looking at this term, so I can figure that out, I'm going to have 2 seconds squared, which is going to give me 4. I'm going to look over here at this 1/2. I'm just going to take 4 divided by 2. That's going to leave me 2. And then 2 times 1.5 will leave me 3 meters. So my answer, 4 plus 3 meters, 7 meters. And that's it. That's all for now.